This is the third video in the series Getting to Know Cimatron Die Design. This follows where we left off in our last video dealing with forming conditions. Our discussion today focuses on analyzing the part for tearing and wrinkling conditions, calculating springback, and looking at some advanced forming conditions and how it affects the analysis outcome. Our presentation today will begin by using the blank function to get a 2D profile perimeter of the bracket you see on screen. Once we have the blank, we can run the analysis tools, which are also an option available within any of the blanking functions themselves. We will accept the material that has been chosen previously in the setup file and now let the blank calculate. We can now use show analysis to interrogate the part. The first thing we're going to look at is the thickness strain. A negative value indicates that the part is thinning out and could possibly tear, whereas if that value increases, it would indicate that the part could wrinkle. Another tool at our disposal is the safety zone analysis. In this case, no areas are shown in red, suggesting that they would completely tear, but there are some dark blue areas showing a strong wrinkle tendency, meaning that the material is stretching on one side and compressing on the other. The third option is spring-back analysis, which will predict how much the part will spring away from the tool form based upon the material properties and the geometry of the part. This analysis can show us the magnitude or total displacement of the springback, and this gives us an option then too to create a springback STL file, and also can show us the deflection, which would be a projection or normal of that magnitude of displacement. To deal with those areas having a strong wrinkle tendency, a preform shape may be used. This preform shape was created using blank on binder with the intent of stretching the material as it's being formed. To do this, we're going to use the blank function again, but this time also include the options of advanced forming conditions. This allows us then to calculate the blank using things such as pressure pads and draw beads. So here we select the area that's going to be restricted, such as that center pressure pad area, and then we apply the amount of pressure. With the blank calculated, we can now look at the analysis. The thickness strain analysis shows us that, unlike before, we now see an area on the part that is thinning. And the safety zone analysis shows a marked decrease in the area having a strong wrinkle tendency. Finally, then we'll run the calculation for the springback analysis. Keep in mind that all this can be done on any form and not just a flat blank. And here we can see that the overall deflection has greatly reduced because we're not forming the entire part at once. We're not bending the sidewalls down. Thank you for viewing this presentation. Please look for our next video presentation in this series on the subject of strip design.